Given a circle of radius 3 in a sine ratio of a position, the sine ratio is given as 0.279 for the position angle theta. Determine the coordinates of the point on the circumference that defines the terminal arm. So first of all, we have to remember that there are two positions that are possible here. And what I'm going to do is I'm going to start with the sine ratio. And because the sine ratio represents a vertical position of a unit circle, I'm just going to draw in my unit circle with radius 1. And I need to zoom in a little bit, but that length, the vertical length here, is going to be 0.279. Okay, so that's going to be the actual vertical length of that position. What I'm being asked for is I need a bigger circle with radius 3. So this circle, red circle, has radius of 3. So my radius 3 circle, and I want to find the point on the circle, just on the circumference of the circle. Okay, we need the coordinates of that point. Well, if my vertical position on my unit circle is 0.279, then the vertical positioning on a circle that's 3 times bigger is going to be 3 times 0.279. Okay, and that positioning is going to work out to be 3 times 0.279, and that's going to be 0.837. So 0.837 represents the vertical position. The horizontal position we can get by Pythagoras. So we can use Pythagoras on that unit circle. So we're going to go 1 squared minus 0.279 squared, and that we're going to square root that value, and we get 0.960. So using Pythagoras, and maybe I'll write it down here. So we know that we'll call that length x. We know that x squared is equal to 1 squared minus 0.279 squared. And we get x is equal to 0.9, I think it is 922. And that allows us to solve for x, and the x value is 0.960. Okay, so what that means then is in this little circle, that length is 0.960, which means that in the bigger circle, this length is 3 times 0.960, and that gives us a value of 2.88. Okay, so that's approximately 2.88 along the horizontal. So then if I were to locate the position of this point, it's going to be 2.88 and 0.837. And all I've done is I've scaled the smaller triangle 3 times to get the positions on the larger triangle. So we can use, this is using the unit circle as a base, a unit rate that we can scale. Okay, and I forgot that this is, since this is in quadrant, so if there's a positive sine ratio, we can also do this in this quadrant here, and we end up with another position we'll call P2. Okay, so this is P1, P2 will have a position of negative 2.88 and 0.837. In example 3, we have a point MN, and we can put that point in any quadrant we want, but to make things simple, we're just going to put it into quadrant 1. And we try not to put it at 45 degrees because when we do, we imply some symmetry which may not exist in the problem. So I'm just going to put it here in quadrant 1. There's my point MN, and it's a terminal arm on a unit circle. Well, that's key because if that is on the unit circle, remember I can define the x and y coordinates as cos and sine ratios. So it says here, determine the value of, so this is my angle theta. It says determine the value of sine theta and secant theta. Well, I know that that is sine theta. The vertical position is going to be sine theta. So sine theta is equal to n. Okay, we know that this position here is going to be cosine theta. Okay, and so that secant theta value, secant theta is going to be 1 over cosine theta. So then that's just going to end up being 1 over whatever that length m is. So sine theta and cosine theta, or sorry, secant theta.